Hello, welcome to my video presentation for the course final project MFG 598. In this project, I did vegetation detection using the machine algorithm KNN model. So vegetation detection is very important for urban planning and also in agriculture, as the green areas are crucial for land management and also the resource management. Traditionally, the analysis would be done manually, but that would be very time consuming and prone to human error. And that's why we can see the need for an automated, more accurate system. In this project, I used advanced image processing like the CP2 Python package and machine learning techniques like the scikit Python package. It is important to note that this project was done for vegetation detection, but it can actually be applied for any object detection that the user desires if that object depends on color features. So as I mentioned in this project, I applied the KNN machine learning algorithm, which is a very common technique. First, we start by selecting the k-value, which is the number of nearest neighbors the algorithm will consider, and then we will calculate the distance between the points. We can use different formulas, but the most common one is the Euclidean, and also that's what I applied in this project. After calculating all the distances, we will sort them based on ascending order. From this sorted list, we can then select the top k nearest neighbors, and the final step, we will classify the task. The KNN predicts the class of the new data point based on the majority of the votes among that k nearest neighbor. And then the class that is receiving the most votes becomes the predicted class for that new data point. So in this project, we started by getting the trained data points, and then I applied a validation step. So for getting the trained data points, the color features that was used was different values like the RGB values, the excess green, and the color index of vegetation extraction. So the trained data are actually input by the user, meaning that the user can draw polygons on different images that they want to be the trained images, and then they can assign manually the labels for vegetation or non-vegetation as the number of 0 or 1. So in this project, I used two images to get the trained data points, and I had around 73,000 data points. And at the end, I had one image to test for the validation. So in the script number 1, we draw the polygons to collect the data points using the callback function from the mouse. The user inputs the image, and then the user can click the left button to collect the points for the polygon, and then they click the right button, and then they can extract the XYZ and DXL points RGB values, and then manually assign 1 or 0 as vegetation or non-vegetation. So the user keeps drawing polygons or inputting different images if they want, so the trained data is complete for the KNN training. So after that, the KNN model was trained. I used the k-value of 3. I saw that the accuracy was around 89%, which is acceptable. And then for the confusion matrix, we can see that around 9,000 points were detected as non-vegetation correctly, and around 4,000 points were detected as vegetated area. And the false positive or false negative was around like 1,500 points, which is acceptable. And then for the validation image, I applied the trained KNN model to it, and I saw that the Python script showed that 75% of the area was non-vegetated and only 25% was vegetated. So in this project, I used the whole script for vegetation detection, but it can actually be used for any object detection that the user wants. Thank you.